Hey everyone, my name is Jordan Zenko and I'm the Community and Content Manager for Dundas Data Visualization. For those of you who are active in the Cube, which is our exclusive VIP program for customers, may be thinking, hey, that guy looks pretty familiar. For those of you who aren't though, it is a pleasure to introduce myself and I hope that you get yourself involved and participate in our program. If you've attended any of our webinars in the past, you'll notice that this is a little bit of a different format than what you're used to. The reason for this is because we wanted to create something that's a little bit more engaging and something that's easier for you to digest. Now, this is a pre-recorded webinar, but that does not mean we won't be live at the end of this. So please do prepare any questions that you may have and we'll answer them at the end of the webinar. Now, the last bit of housekeeping we have to do before jumping into the webinar is a little bit of background on Dundas. We are a leading global provider of business intelligence and data visualization software and provide dashboards, reporting, and visual data analytics all through a fully embeddable BI platform. Our flexible BI platform can be easily integrated into any of your existing systems or applications, enabling you to easily access, visualize, and analyze any data on any device for deeper, faster insights. Now, while this video is going to primarily focus on the visualization aspect of our product, Dundas BI can handle much more than just that, and I welcome you to visit our website once this webinar is done to find out everything you need to know for yourself. Alright, let's get down to business. If you're watching this video, I'm going to assume it's because you want to create best practice, interactive dashboards, and rich reports using cutting-edge, advanced, visually stimulating data visualizations. That's great, because over the course of this webinar, we're going to be taking a closer look at 10 advanced data visualizations that are native to Dundas BI. These are visualizations that we offer out of the box that'll take your visual delivery to the next level. They'll help you understand your data faster, they'll get your users engaged, and they'll help you convey the message that you're trying to get across. Now, I just need to point one thing out right off the bat. While all of these visualizations that I will be showing you today are real-life examples that we've created in Dundas BI, I won't actually be creating any of them from scratch today. They've all been pre-built with the purpose of teaching you two things. The first thing is when it's actually appropriate to use each data visualization. And the second thing is how each visualization can elevate your ability to effectively communicate data insights beyond standard visualizations. Now, before we jump into all that though, I'm just going to go through one more thing. I'm going to cover the whats and the whys of data visualizations, specifically in how it relates to business intelligence and Dundas. So what are data visualizations? Data visualizations are the modern equivalent of visual communications. And what I mean by that is that data visualizations are interactive representations and techniques that are displayed as visual objects. The purpose of them is to clearly communicate the significance of data to those who view them. By using data visualization, certain patterns and trends and correlations that would typically go hidden in non-graphic renditions, such as text-based data, are more likely to be revealed and identified now. Business intelligence tools such as Dundas BI enable you to get greater insights out of your data and enable you to step beyond the confines of traditional reporting tools with extremely interactive and highly engaging data visualizations. Data visualizations are so important to business intelligence, and it's for the reasons that I just mentioned that we at Dundas put so much time and resources into creating data visualizations that really help you create best practice, interactive dashboards, and rich reports for complete data insight. Without this intense focus, our customizable and smart data visualizations wouldn't be nearly as famous as they already are in the industry today. Now, as you're well aware, virtually all business intelligence platforms feature some type of data visualization component. However, what separates Dundas from the pack are our hallmark, smart data visualizations that represent over 20 years of technology leadership and innovation. Our data visualizations are rich, extremely flexible, beautiful to look at, and above all else, highly customizable. It's their extreme customization properties that arm you with staggering granular control over almost every single visual design element. Alright, without further ado, let's get into it. I'm going to be covering 10 advanced data visualizations that are native to Dundas BI. I'm going to cover what these visualizations are, when they're most appropriate to use, and why you should consider using these visualizations over some of the more traditional options. So what I've done is categorized each of the 10 data visualizations into 3 distinct categories. Let's take a look at what these are. Alright, so let's finally get into this. 4 of our advanced data visualizations fall under the relationship category, and the first one that we're going to be taking a look at today is the relationship diagram. The history of the relationship diagram can be traced back to the early 1900s to a man by the name of Jacob L. Moreno. Moreno was a leading social scientist of his era, and many people considered him the foremost pioneer of group psychotherapy. At the time, he developed what he called sociograms. Moreno's sociograms were used to diagram different structures and patterns of various group interactions. And much like the sociogram, the relationship diagram shows interconnectivity and helps to illuminate just different types of relationships between groups of entities. But what exactly is the relationship diagram? Well, it's a collection of nodes that are connected to other nodes by way of links. The nodes are typically shown as circles, and the links, which connect the nodes, are typically straight lines or curved lines. Now let's take a look at what the relationship diagram looks like in Dundas BI.
What we have here is a relationship diagram that's showing character co-occurrence in the famous French novel Les Miserables. What's really unique about the relationship diagram is that there's a physical simulation of charged particles and springs that actually place related characters in closer proximity and unrelated characters farther apart. You'll notice that we're actually able to drag the nodes to different locations on the dashboard in order to reposition them. However, as you just noticed, the physics of this diagram do ensure that the nodes spring back to an extent and return to locations that are closer to the nodes they have a greater relationship with. In this case, it's placing the characters who are related to one another back together and those who aren't further apart. Another really useful interactivity that this visualization includes is the ability to zoom in and out. What this does is it allows us to see groupings and relationships more clearly. For example, let's zoom in on one of the characters, Valjean. So by zooming in on this character, we can easily see that he's very closely related with a high number of other characters in this plot. We've added one last little bit of interactivity into this visualization that's pretty fun. And what this is that we'll actually link to Google when any of the characters are selected. So again, if we go back to Valjean, this is what would happen if we click on him. That's pretty awesome. So if you ever want a little bit more information, you can actually go directly into Google and look up that character. Now, what sets the relationship diagram apart is that it's really great at analyzing and uncovering hidden relationships within data that other visualizations easily miss. For example, where other visualizations may show the relationships implicitly, the relationship diagram actually displays explicit connections between many different data points at a glance.
The second visualization that falls under the relationship category is the Sankey diagram, and it's really quite unique. It's often considered a sister visual to the relationship diagram. However, where it differs is that it displays its relationships in a flow, as opposed to by connections without any specific structure between them. Like the relationship diagram, the Sankey is comprised of links. However, in this case, the width of the links in the Sankey are proportional to the magnitude of the flow. Believe it or not, but the first Sankey diagram was actually fashioned back in 1898 by an Irish captain by the name of Matthew Sankey. A far cry from the stunning diagram it is today. Captain Sankey's Sankey diagram only displayed one flow. So let's take a look at what this looks like in Dundas BI.
What we're looking at here is a Sankey diagram that shows the flow of a website's visitors as they navigate their way around the site from one page to another. This is a really effective diagram for this type of scenario as it helps to highlight popular flows and validates to us that the website is designed in the way the visitors intend to use it. You may have noticed, though, that in this example, some of the flows appear to be moving backwards. For example, you can see right here between our try and buy page backwards to our product page. The reason for this is because website navigation isn't always linear. The reason why you're going to be seeing a flow moving in reverse from this page back to our product page is because that's the path that our visitors chose to travel. They may have landed on the try and buy page first, but they decided, we need to know a little bit more about the product before we advance with a demo or something like that. And while the Sankey diagram is great for at-a-glance monitoring, upon hover you can actually see the exact flowing quantities if you needed to. For example, we can see that 5,000 users moved directly from our home page through to our About Us page. You're probably imagining by now that this diagram has the potential to become very cluttered if the number of flows far exceeds the sample that we've created. No reason to worry though, as the Sankey diagram is highly interactive and we're actually able to drag and reposition the bars as necessary in order to make some room. So if we didn't want this try and buy section right here because we thought it's looking a little busy in the middle, we could simply move it down to the bottom of the diagram. You've probably already gathered by now, but this is a very flashy, attention-grabbing flowchart and is typically used when visualizing distribution and loss of values. Some of the most common use cases are when analyzing energy loss, money, or materials across a flow.
There's a good chance that our next relationship type diagram is one you're all very familiar with, and that would be the tree diagram. Presented like a tree, hence its name, this visualization displays information about the rank structure of data. What this means is that by using the tree diagram, we're actually able to visualize hierarchical data breakdowns and interrelationships between categorical items. The tree diagram shares a lot of similarities with the Sankey diagram in that they're both designed to show relationships as a flow. However, unlike the Sankey diagram, whose link widths are proportionate to the magnitude of the flow, the tree diagram really focuses on the different paths of data that are available. The typical structure of the tree diagram consists of elements such as nodes and branches, whereby the nodes are connected to the branches and represent the relationships and connections between members. Here's what a tree diagram looks like in Dundas BI.
What this tree diagram is showing is the breakdown of sales across countries along with their respective sales executives. You'll see a branch on the left with Canada, the USA on the right, and the respective sales reps branching off below that. If you look closely enough though, you'll notice that some of the sales reps' images are larger than the others. This is because we've customized the size of the nodes to reflect their numeric values. In this case, the size of the sales rep will actually vary depending on their sales performance. If we take a little bit of a closer look, we can immediately see that Linda, for example, has been outperforming her fellow reps Jose and Michael, and we can tell this solely based on the size of her node. This is a really smart feature as it means we're able to visually review the entire sales team at a glance and can quickly identify which sales reps are the most successful. In this example, we've also added a button on the left that allows us to toggle between using images for each node to focus on the sales rep for simply focusing on the node size. Now let's take a look at this. Now, while our example is certainly a suitable scenario for when a tree diagram could be used, they're best used when displaying organizational charts and other family descent-like structures. For example, another good use case could be when displaying the different origins and classifications of different types of species.
The fourth and final diagram that falls within this category is one of the most difficult visualizations to properly explain. And the reason because of this is because it allows us to see the relationships in data from an entirely different perspective. Often a misunderstood visualization, the chord diagram displays the interrelationships between categorical items. With a chord diagram, our data is positioned radially around a circle with each node or slice corresponding to a different category. The relationships between the nodes are then drawn together with big sweeping arcs, the widths of which that are proportionate to the magnitude of the flow. What we're left with is a remarkably visually appealing visualization that's surprisingly easier to digest than the more commonly used pivot tables. This is especially true when attempting to measure movement between categories. Now, like I said, the chord diagram is a little bit difficult to properly explain, and I'm probably not doing it justice, so let's just skip right ahead and see what this looks like in Dundas BI, and we'll go from there.
So here we've created a chord diagram that helps us to monitor the churn rates of subscribers that are moving from one telecom network over to another one. By using a chord diagram, we're able to immediately see the bidirectional paths of customers that are moving between the various networks. You'll notice that the interactivity of this visualization makes it quite easy to identify the leading telecom providers in regards to churn rates and where the new subscribers are coming from. As you can see, the brushing that appears on hover really helps us to make these identifications. And if we wanted to be even more precise, we could simply hover on one of the flows and determine exactly how many subscribers change networks. For example, we can see here that over 2,500 customers have made the switch from Sprint to Verizon, whereas less than 200 have come to Sprint from Verizon. This insight would have been very tedious and much more difficult to conclude if we'd used other more commonly used table-type visualizations. And as a telecom provider, this can be very useful when validating the success of specific campaigns that really promote the movement from one provider to another. So you may be wondering though, outside of this example, when would it be most appropriate to use a chord diagram? Well, first, it's important to remember that while other relationship type visualizations show hierarchical relationships between data, the core diagram actually visualizes the relationships at the same level. And what I mean by this is that the core diagram is most powerful when visualizing the relationships between single level hierarchy members. So hopefully that clears up some of the confusion you may have had around this visualization.
Alright, that covers the relationship part of this webinar. Now let's move on to charts. The first chart that we're going to talk about is one of my favorite visualizations, and not just because of how awesome it looks, but because of how it transforms the much maligned pie chart. I'm talking about the sunburst chart. The sunburst chart has many names, sunburst being one of them, radial tree map another, multi-level pie chart yet another. Regardless of what you choose to call it, what the sunburst chart shows is a hierarchy breakdown through a series of concentric circles which are sliced and diced depending on their hierarchical relationship to the root node. The root node, otherwise known as the parent node, is the first part of the data structure which then links to multiple nodes that contain data fields. To summarize all that, the sunburst chart allows you to drill down into your data without filtering the original members. Let's take a look at what one looks like in Dundas BI.
Now, this visualization is simply stunning, and you'll see why in a minute. Plus, it does a great job at both representing hierarchical data structures and increasing your users' engagement levels. What often gets lost in the simplicity of a circle are these intriguing, distinctive qualities, and what many assume they lack in precision is gained with an intuitiveness and beauty that just feeds our fascination. But if there were to be a significant downside to the sunburst chart, it would be that it can be quite large and take up a lot of space on your dashboard. You can probably already gather that just by looking at it. That being said, the sunburst chart allows us to easily interpret it at a glance and can generate an immediate response. It's tasteful, it's simple, it's ideal when representing hierarchical data structures, and above all else, it's effective. So enough chit chat, let's take a look and see what this actually works, or see how it works. Keeping with the trend of cellular connectivity in mobile devices, what we have here is a breakdown of the market share of different mobile operating systems. Each color we have represents a different type of OS. You can see there's Android, iOS, BlackBerry, so on and so forth. We then further broken it down into their specific versions or releases. You can see we've already expanded the iOS slice and the Android slice. But your sunburst chart doesn't have to start like this. It can simply just show your different operating systems. At the click of a button, you can drill into one of the versions, and now you see all the releases that are applicable to it. Again, a simple click, and we can drill right back up. If you want to expand the different slices, you simply click on it and expand it. It's that simple. Now, you might be thinking that this is a glorified pie chart with minimal use cases, but that couldn't be further from the truth. Sunburst charts are particularly helpful when displaying multiple hierarchy levels at once, and they allow us to visualize data at various levels much easier. Not only that, but they're extremely extensible to numerous events and solutions that really have anything to do with hierarchy. One of the first blogs I actually wrote when I joined Dundas was on baseball, and I used the sunburst chart to really show how you could break down a batter's balls in play. So really, it's a very versatile chart.
Alright, on to chart number 2. We're halfway through our 10 advanced data visualizations. The next one that we're going to be taking a look at is the waterfall chart. Now, if there were ever a chart that deserved a gold star for measuring changes over a particular sequence and how those changes impacted the total, the waterfall chart would be the one. The waterfall chart clearly illustrates the cumulative effect of a sequence of events or a process that has different transactions, some positive, some negative. In other words, what the waterfall chart allows us to do is simply understand how we got from point A to point B. More often than not, when we're observing the incremental changes of individual values over time, we tend to stick with what we know best, which usually means we use the bar chart as our go-to visualization. The problem with using a bar chart is that it can only offer a decomposition of each value. This means that it won't be able to emphasize the status of the aggregate balance. This is where the waterfall chart really shines. It's an incredibly precise and versatile visualization that shows both static and active data, whether or not the value is positive or negative, along with the final total. Let's check it out in Dundas BI.
So this waterfall chart here is showing us the monthly balance of different Office transactions. You'll notice that negative transactions are marked in red and positive transactions are in blue. You'll also notice that we have a highlighted grid line at the value 0. This is really important as it helps us to see at a glance whether or not the cumulative value of the transactions is either positive or negative. What's really great and unique about the waterfall chart is that it displays changes in the aggregate as either an abrupt increase or decrease from its prior value. For example, it's easy for us to tell that immediately after our salary deposits took place on June 15th, which is a negative value, our total monthly balance rebounded the following week with a large amount of customer renewals coming in. If you wanted to see the exact transactional value, all you would have to do is simply hover on the bar you're interested in. So for example, on June 25th, we can see that we received exactly $3,110. Some of the most widely used examples of waterfall charts are for balance sheets, income statements, cash flows, and other sequences that really ebb and flow quantitatively. The reason for this is because these abrupt shifts occur more naturally with this type of data. It just makes sense to use a visualization that's reflective of something like that.
The next chart that we're going to take a look at is the Pareto chart, and it's an interesting visualization in that it uses bars along with a line graph. Its individual values are represented in descending order by bars, and the cumulative total of those values is represented by the line from left to right. So let's get right into it and see what this looks like in Dundas BI so that we can better describe it.
So what we have here is a Pareto chart that's showing the 2018 breakdown of the market share of various internet browsers. You can see that the bars have been arranged in descending order and the line begins at the top of the first bar. As we move right towards the second bar, the line value is now the combined total of both bars as a percentage. The line represents the total share of the items, which in this case is Chrome and Safari so far, out of the entire group of items. And once we then make it to the final bar, the line will always be 100%. What you may notice is that the line after 3 bars is roughly equal to 80%. Actually 80.03%. Now, this is a very common occurrence as this chart is actually a derivative of the Pareto principle, hence its name, which states that for many events, roughly 80% of the effects come from 20% of the causes. This principle dates back to the late 1800s when an Italian engineer by the name of Vilfredo Pareto observed that 80% of the land in Italy was owned at the time by 20% of the population. He further developed his theory when he observed that roughly 20% of the pea pods in his garden contained 80% of the peas. So you might be wondering, when is the best time to use the Pareto chart? Well, we know that the Pareto chart views causes of a problem in order of severity from largest to smallest. So with this, we're able to highlight the most important values among a large set of factors. The most prevalent use case would be for quality control, specifically in regards to identifying the most common source of defects or the highest occurring defect, or maybe the most frequent reason for customer complaints, stuff like that. But that being said, this visualization can easily be applied to other events such as business, where 80% of profits are regularly tied to 20% of the products.
Our next chart, simply put, is not pretty. At first glance, it's cluttered, it's quite indecipherable, and has many overlapping lines. This is the parallel coordinates chart, and luckily, aesthetics is not its forte. Before taking a look at the parallel coordinates chart, and before determining its value, it's important to set aside any reservations you may have about its resemblance to a line chart. Because unlike the line chart, which indicates change over time, the parallel coordinates chart connects a series of values, each one associated with a different value, and measures multiple aspects of something. In other words, as that definition is rather broad, the parallel coordinate strengths lay not in its ability to communicate the truth of data, but rather to bring meaningful multivariate patterns and comparisons to light. So let's get down to it and see what one looks like in Dundas BI.
Pretty snazzy, right? What we have here is a parallel coordinates chart that shows U.S. universities across multiple variables. By using this chart, we're able to better benchmark and distinguish some universities from the rest based on different variables that have all been normalized as percentages. Some of these variables include earning, grad debt, SAT average, school size, and more. The reason they've all been normalized as percentages is so that they can be compared on an even playing field. As we hover on the visualization and move through the various universities, you'll notice there's a brushing effect that highlights the schools that we've selected. This way, we're able to see all the attributes that are applicable directly to that school. We're also able to come to some conclusions this way. For example, let's look at the University of Pennsylvania. In this sample, we can see that these graduates actually gain much higher earnings after 10 years compared to most other schools. Yet, the SAT average required to get into this school is not as high as you might expect. Now, analyzing multivariate data is no walk in the park. It often boils down to the analyst's ability to see all of the different combinations displayed together at once in order to quickly identify patterns and make comparisons without having to isolate two variables at a time. This is why the parallel coordinates chart is such a powerful and handy visualization. It allows us to look at a lot of data points at the same time and see how close specific measures are in regards to patterns or how they stack up against measures in the same category. Now, in addition to our university example, the best use cases for the parallel coordinates chart is when comparing an array of products with same attributes. For example, it's a really handy visualization when comparing computer or car specifications across different models.
The next visualization we're going to take a look at today is the range bar chart. This is a chart that should look familiar to many of you because it is a bar chart that displays bars for each dimension or category ranging between a start value and an end value. Now, in order for this bar chart to actually be considered a range bar chart, it must have at least two measures, which are to be used as the start value and the end value of your range bars, and at least one hierarchy. For example, the measures may represent the high and low temperature values for a given day, and the hierarchy will represent a specific date. Here's an example that we just came up with in Dundas BI.
This range bar chart is showing project development plans using different project phases and milestones. You'll notice there's much more than the minimum two categories. We have several stages of development in these: design, build, test, operational assessment, and so on. But we only have one hierarchy, which in this case is date. The reason why the range bar chart is so useful in this situation is because it allows us to, at a glance, see the current state of each project and informs us if we're hitting our predefined milestones or timelines when we're supposed to. Now, the reason we chose this as our example is because the range bar chart is particularly great at tracking measurement ranges, tasks, and project schedule adherence. Projects often have multiple phases, and each has its own milestones and dependencies. The extreme versatility of the range bar chart means that we can accurately represent the beginning and end of operations along a time axis and can easily show our milestones and dependencies within a project phase. You'll notice that by hovering over certain bars, we can also see the exact steps and timelines for each project. So, for example, you'll notice that the testing stage in Project 2 is slated to begin by October 1st of 2019, and it should be finished by May 1st of the following year. Now, what if you don't have a project and are interested in using a range bar chart? Could you still use this chart on other occasions? The answer is absolutely. When the range bar chart was developed in the mid-90s by a Brazilian trader by the name of Vicente Nicolelis, its purpose was to view and utilize the volatility of markets. Vicente had recognized how unstable the markets were and had become increasingly interested in developing a way to capitalize on that instability. So, enter the range bar chart. It was Vicente's belief that by using the range bar chart, he could take solely price into consideration and eliminate time from the equation entirely. This would ultimately allow him to interpret the volatility and predict the opportune times for trades.
And last, but certainly not least, are advanced table visualizations. We're going to be wrapping this video up shortly, so we're going to just dive right into this one. We're only covering one advanced table visualization today, and that is the correlation matrix. Let's see what it looks like.
As you can see, this is a table that displays the same variables across its rows as it does its columns, and whose correlation coefficients are mapped from -1 to +1. You'll see that the values that fall diagonally along the table from top left to bottom right will always have a value of +1, as this is where the variables are always correlated to themselves. Conversely, with the correlation matrix being a grid, its other diagonal values, these are the ones that fall along the table from top right to bottom left, will be symmetrical. The reason for this is because the correlation between variables x and y, for reference in the chart that you're seeing, dew and temperature, are the same as variables y and x, or temperature and dew. But let's take a closer look at the correlation matrix we've created. In this example, what we're seeing is a matrix that shows which weather variables impact, or don't impact for that matter, each other. For example, one of the conclusions that this matrix is suggesting is that there may be a negative correlation between wind speed and dew quantity. And if we wanted to see that exact correlation value between these two variables, we'd simply have to hover on that specific cell. So by doing so, we'll see that the correlation value is actually negative 0.71. Ultimately, what you get with the correlation matrix is a complete view of the bivariate correlations that exist in whatever dataset you're looking at. It's an extremely powerful visualization to use when highlighting the positive and negative dependencies between multiple variables within your data in a single visual, rather than having to analyze and look for hidden dependencies one variable at a time. This table can be used for any number of situations where measuring meaningful relationships is the objective, such as identifying the next steps in a marketing campaign, improving the design of a website, continuing in-depth analysis on customers for additional correlation dependencies. The list really goes on and on. So that was the last visualization that we'll be covering today, which means that our webinar is now coming to an end. I just wanted to thank you all for attending, and I hope that you found these visualizations as intriguing and as impressive as I did. We've really only scratched the surface on the types of data visualizations that Dundas offers, as well as the functionality that each possesses, so I really encourage everyone to test out each one in greater detail for themselves. We provide a great array of visualizations, each one varying in complexity and intent. So really, which ones you choose to use depends heavily on the data that you have and ultimately on the story that you wish to tell. Dundas's customizable and smart data visualizations are famous in the industry, and while it's unlikely that you'll need to, or really even want to, use all the visualizations that we discussed today, I'm certain that each of them will be able to satisfy the needs of your end users. So using your datasets, I invite you to get your hands dirty and really explore for yourself what discoveries you can make with Dundas BI. Also, as a quick side note, these 10 data visualizations will also be made available for download as an ebook shortly, which will cover everything we've gone over today. Alright, so that concludes this webinar. We'll now take this live. I'm going to pass this off to my colleague Ariel, our Director of Product Marketing, and he's going to answer any questions that you may have about what was just discussed.